just to let you know, this is CLJS Hackers. Thanks for coming. My name is John. And Justin Oliver Lee is also on here. He's another co-organizer. If you have any talks or events that you'd like to do, you can Slack any one of us, and yeah, we could get you scheduled. So without further ado, Yang, I'll let you introduce yourself and get started.
Great. Hey, everyone. My name's Yang. I'm basically working on this project called Plasmic, which I'm excited to be here and share a little bit about today. I guess my own background is I actually came from more of a back-end sort of background and did more like distributed database systems and machine learning. And then over time, actually got more into front end and kind of developed a love for that kind of work, being closer to the user, et cetera. So so now, at this point, I've spent a while just focusing a lot on building products and building front ends using React and other systems. So. Awesome. Oh, sorry. Did you want me to go ahead with the presentation, or?
Yeah, go for it.
Okay, cool. Great. Is it possible for me to share the screen? I think actually, if you can, there's two of me in this meetup. If you can let the other Yang share the screen, that would be awesome, because I actually that's the one with that's the
computer. Yeah, go ahead and give it a shot.
Okay, great. Is that coming through?
Yeah, that's good.
Okay, great. Yeah, thanks for being here. By the way, as I'm going through my my presentation, please feel free to interrupt me with questions, and I like to make this as interactive and conversational as possible. I probably won't be able to keep a super close eye on that chat box, so feel free to interrupt me on anyone's behalf as well. So yeah, excited to be here and talk about Plasmic. It's something that started a while back for me as a passion project, and I hope it can be useful just as a tool for all React developers and eventually, front-end developers in general. But also just interesting to learn about and talk about as a React project itself. It's definitely been a big source of challenges and learnings for us. So I'll talk about that today. So maybe first, just to cover what is Plasmic and why I work on it. So Plasmic is a visual builder for React, and worked on it to solve two different problems, basically. This is the first one, which is that actually, before continuing, I'm curious to kind of gauge the audience a little bit. Maybe there's a good way to do this in Zoom, but how many of you work with a designer? And if you do, maybe just mention that in chat. I'm always curious to just poll the audience on this. Cool. A couple people are connected with designers. Oh, nice. Actually, quite a few people who are actually hybrids, the rare breed. Awesome. Cool. So yeah, my own experience is actually that most projects I've worked on, I haven't been able to work with a designer. Whenever I do, it's always a lot of fun, and I learn a ton from that experience. But yeah, majority of projects I work on, it's more, usually in startups, it's more of a Wild West. And whenever I do get to work with a designer, it's fun, but also it can be complicated in terms of like the collaboration and the handoff process, because basically what happens is, designers, a lot of designers I work with, they're used to these design tools that are great, vector drawing tools. And so they create these high fidelity vector drawings, which, as an engineer have to recreate from scratch by hand using code. And inevitably, a ton of things get missed in this translation, because it turns out, in general, we as developers tend to really suck at this kind of rote task. or it can just be hard to translate because designs are completely freeform drawings, right? And so this leads to a bunch of back and forth with designers, and ultimately have these two sources of truth that are never truly in sync. So this is by most teams' admission. So this is the first goal, is to streamline that collaboration and that translation process. Now, the second goal is just a little more selfishly, as a front-end developer, wanting to have a better and kind of rethought development experience for those of us working on front ends. So, this is so we can build a lot faster, but at the same time, eliminate maybe an entire class of visual bugs and QA and related tooling. UI builders are actually nothing new. They're in fact quite widely used, generated perfectly fine code that ships into all sorts of major apps for a long time, but mainly on other platforms like iOS and Android and Windows, where there's kind of a clear company owning the platform and creating tools for it. And anyway, want to bring some of that to the web. So that's kind of setting the stage a little bit in a lot of words to say that Plasmic is a visual builder for React, and it's intended to let developers, that's kind of our main focus, but also trying to keep it accessible to designers, basically letting developers or designers craft complex presentational components that integrate and that you can import into your your real world messy sprawling React code base. And the idea is to let you move faster and fix designer developer collaboration. So that is the high level of what this is. And now I'll switch gears into a demo to kind of show what Plasmic is, how it works. And from there, I'll peel back the curtain and kind of talk about a little bit how Plasmic works and what we did to build it. So, and basically, by the way, as I'm going through this demo, I invite you to kind of think about, as you see kind of all the moving parts, to kind of dissect and start thinking about, like, how would you go about, if you were to recreate Plasmic or build, a tool similar to it, how would you go about doing that? And then, I'll talk about our approach. So Plasmic kind of starts off very simple. You have this empty canvas, and this is one way you can start, which is just to start from scratch and create everything from scratch directly in Plasmic. There's actually another way to start, which is importing from existing design tools, but I'll talk about that later. For this demo, I'll just go through this from scratch workflow. And for this, actually, maybe just to show you to do MVC, this is what we're going to be creating. Not the whole thing. I'm just going to create a small subset, loosely approximated. So, this is everyone's favorite sort of reference app. So here, I'm just going to add some text for the title, just roughly, placing it in the middle here, and I'm going to style it to be a certain style and color. And, I'm just, roughly drawing things on the screen, not, using real layout or anything, just absolute positioning everywhere. And same thing with this card for the actual task right below it. Maybe I'll draw a box for the actual checkbox in there. These are just kind of wireframes, but I'll style them to look higher fidelity. So I'll set the background of the whole page to be maybe this off-white warm gray. And maybe I'll make this task itself white background, and I'll set this checkbox. I want it to be a circular checkbox, so I'm going to make it completely rounded, and I'm going to remove the background color and add some real light border around it. Now, right next to it, I'll add some text for the actual task itself. So buy some milk. I'll make this font a little bit bigger. Yeah, that's better. And maybe I'll make the text slightly lighter color. I'll save this color actually as a reusable text color, a reusable color token called text color. Yeah, that's pretty much what I wanted to do for designing this task. Oh, this is like way too light. Maybe something like that. So anyway, this is the kind of flow and iteration that Plasmic tries to enable, is just like really quickly slapping ideas on the screen. And from there, you can start from scratch, and then from there, refine it into something that is robust and for production. So we'll be seeing that in action here. So far, I have this one task, but I actually want a bunch of these in my task manager. So the first thing I'll do is right-click this and create a component out of it called task. Now I can instantiate this a bunch of times from here, just creating a bunch of these. I kind of roughly arrange them in this vertical list, but let's say I actually want them to be organized into a real layout. What I can do is I can wrap them in this in these stacks, like in this case a vertical stack, and these keep everything distributed or aligned for me. And it's basically under the hood it's Flexbox, but basically with some additional bells and whistles and basically streamlined controls on the right to make things a little more intuitive and faster. So some simple examples of that are, first I'm going to clear out the background. I'm going to snap everything to the top and to the left. I'm also going to double click this edge here to auto size to the content vertically and maybe horizontally as well. These are some simpler features, and we'll see some more interesting features in a little bit. I'll call this whole thing my task list just to keep my elements organized, and also it'll come in handy later for the actual code generation part. By the way, I'm going through this kind of quickly just to show you how it works, but feel free to just stop me with questions at any point. So I'm just flying through this. This task here, if I double click to start editing it, I can make changes to this thing and they propagate to all the instances of this component. I'm actually going to undo that. These tasks, they all have the same text, which is kind of boring. I actually want that to be different. And in fact, I want this text to be variable. So what I'm going to do is I'm going to double click this component to edit it again. I'm going to select this text and I'm going to say convert it to a slot. And what that does is from outside of this component, from any instance, I can select that slot and I can customize the content. So make to-do app, give a demo. But I can, besides changing the text, I can fill it with arbitrary other elements as well. Now, the only other thing I wanted to do with this component is design it out in its different states. So I'm going to, before doing that, I can actually right-click any component and say I want to edit it in its own new artboard to the right. So this just pops it out and it gives me a space to edit it. This is basically, artboards are just like views of a component. You can create as many of them as you want. And if you're familiar with something like Storybook, it's the same general philosophy of letting you focus on one thing at a time. Now, from here, the way that states and variations and things like that are modeled in Plasmic is through this unifying concept called variants. And the way this works, I'll just show you by example. I'm going to create a group of variants called states. And maybe the first state that I'll design for this component is what it looks like when it's completed, what it looks like when it's marked, when it's being edited, or when it is set to high priority. So these are different states that I can design for. For this demo, I'll just design what it looks like when it's completed. And in this state, I want there to be a check mark in the checkbox. And so for that, I actually like the look of this check mark from the reference app. So I'm going to screen grab it here, like so. And come back here, paste it in. I'm going to zoom into a pixel grid and kind of just position it. Actually, you know what? I can use real layout here and just set it to be centered. There you go. So I'm not positioning it manually like a savage. Now I have this completed state and my base appearance, so I can switch between these. And so what's going on is it's basically, these variants are overrides or deltas on top of the base appearance. It's not like a completely separate hard copy of the component. To show you that in action, I'm going to actually duplicate this artboard. So I have two views of this task component side by side, and I'm going to set this one on the bottom to be looking at the base appearance and the one on top to be looking at the completed appearance. And if I make changes to the component, they get reflected and propagate into this this completed appearance. But things that I record specifically for the completed state of this component are just limited to as overrides in that state. And so if I, for instance, select this text and I decide to make it strikeouts and also just a lighter color, I can directly manipulate these things, and they get recorded as overrides for the completed state specifically. Hopefully that made sense. I feel like I spent a lot of words just now trying to describe this, what's going on. It's a little, yeah, I guess variance might be the most complicated part about this model. But it's very dynamic and it's very expressive. So, if I want to, for instance, have multiple overlapping states, like for instance, let's say I want a hover state for this component where whenever I hover over any part of it, I want this circle to become darker. So I can do that by, I'm going to introduce another variant here. There's actually special support for things like hover states, et cetera, just because, you know, you can represent them in using pseudo selectors and whatnot, and they're just really common. So I'm going to add a hover variant here, and whenever I hover over this thing, I want this circle to become darker. So I'm just going to directly manipulate that, and now I can actually try this out in this preview mode and play with it. And so that's close to what I want, but actually I realize another thing that I want is for the cursor to be a pointer. So now I'll try it again. Okay, that's better. So I have that affordance. And these variants that I've designed come with the component wherever it goes. So for instance, if I you know, go back to my main screen here, I can select any one of these tasks and set it to be in the completed state. And I can also, again, preview this whole thing and kind of play with it. So that's really, I think, pretty much it in terms of what I wanted to do for designing this app. I think the only other thing I'll do is add some real layout to this whole thing, because it's still, you know, everything's absolutely positioned. So I'll set it to be a column layout, and I'll center everything. And yeah, maybe I'll add some padding to the top and bottom here. Great, so that is pretty much it. And I'll actually extract this whole thing. I'll turn this whole screen into a component called the to-do app component. So now in this project, I have two components, my task component and my to-do app component. From here, so now I'm done with this design. Now comes the interesting part of actually importing it into code and using it from there. To do that, actually one quick way to play with it is through this code sandbox integration, where I can just click this button, and what's happening is it's spinning up a code sandbox with all the components that you just crafted in the design tool, you know, already emitted as code imported into this project. So now you can actually look at the code and play with it from here. And by default, you have, you know, pixel perfect rendition running as a standalone web app in React here. So that's one way to play with things quickly, just in the browser. Another way to get going is, this is more interesting, is with your own, you know, local Git repo, you can pull in the components there. And the way this works is there's this CLI tool called Plasmic, and I already have it installed, so I'm going to skip this step. But the next step after that is to run this command Plasmic init, and I'll just go ahead and run that here in this directory. This is a blank create React app directory that I have here. It asks some questions. I'm going to go with the defaults. And the next command after that is to run this sync command, which is actually what pulls down the components that I just created. So I'm going to paste that here. And that should give me the to-do app and task components. And now if I pull up my code editor on the left, so I'll show you the running app on the right and the code editor on the left. So in case you haven't seen a blank create React app, that's all it is. It's just this spinning logo. I'm going to replace all this boilerplate with just getting things onto the screen. So I'm going to render that to-do app component that we imported. So now if I save, then we have exactly what we created in our own code base. So it's as simple as that to get things going. Now, of course, from here, this is just my static mock, and I want to replace this with real data, right? So I'm going to click into this to-do app component. And so inside of this file, this is what it looks like. There's a lot of comments, but it's actually super simple. In fact, if I delete all the comments here, let's see. So like that, then I can see that it is just a one-line functional component. That's just a thin wrapper around a Plasmic to-do app component. And Plasmic to-do app is basically this dumb presentational component that is, you can think of it as, this is a component library that's given to you, like any component library you pull in from NPM, and you just render these, and it provides a flexible interface for overriding any props on any elements inside of it. And then this to-do app file, this is basically yours. Plasmic just generates this for you as kind of a starter skeleton, and you can do what you will with it. But for this demo, let's say I wanted to get some real data reflected on the screen. So instead of this set of 3 static mocks, I'm going to have my own state for these tasks. And so I'm going to define some state, just using plain React state. And maybe my task objects are just simple JS objects with a name property, like so. And to wire things up, I can actually just refer to, for instance, the task list element that, remember, I gave it a name before. Sorry, there's a lot of characters showing up. I'm going to turn that off. I can say that I want to replace this task list, all of its contents, with just my own set of tasks here, which I'm going to loop over. And to render those tasks, I'm going to use the other component that we synced down, this task component, and pass it the name. And so now we have, our own set of tasks showing up. And you can continue in this fashion of just wiring things up this way. So, all the presentational code is already done, and you can add on-click handlers, whatever. You can drill into the task component to wire that up with real logic and business logic and behavior, and so on and so forth. So that's kind of the flow. It's a very simple scheme. Let's see. Now, I think the highlight of this is that it's not like you created the design and then you just eject with the code and that's it. You can actually go back into the tool and make further edits on the design, which is really important for any sort of real world project where you need to iterate. Right? And so in order to do that, I'm going to actually show you Plasmic Watch Mode, which basically live streams any edits that you make in the tool into your code base. So I'm going to have my UI on the right and my my tool on the left. I actually don't have a ton of real estate at this screen resolution, so it's going to be a little cramped. But you can kind of at least see a little bit of what we edit here showing up in the running app. And let's say that I want to make some violent changes to the layout, and instead of this vertical list, I want to change it to a bunch of tiles. So I'm going to double click this component to start editing it. I'm going to make it look boxier like this, and maybe I will give it some real layout, like a row layout, and I'll add some padding all around. I'll snap everything to the top. I'm going to take this checkbox and pop it out of its layout position and actually just have it free floating and move it down to the bottom right like this. I'm actually going to pin it to the bottom right, like so. And let's see, that is pretty much it for this new task look. The whole task list itself is so vertical, so I'm going to change it to a row layout. Now it's spilling out the edge, but I can turn on wrapping, so it kind of wraps around. And I'm going to make it a fixed width, so it's centered. It's a little hard for me to tell apart the tasks, so I'm going to actually add some gap in between things. Like I'll add a gap in the vertical axis and the horizontal axis. So these are showing some more interesting features of the layout engine. And if you think about how to implement something like a cross-browser gap in a way that is tolerant of wrapping and doesn't give you selector specificity issues, it's actually kind of involved. And so yeah, that is. As we were making changes, you could see those changes streaming into your actual code base. So that is the workflow that Plasmic tries to enable. Now I'm going to switch gears, and if there's no questions, I'll go back to my slides. So there are a lot of technical challenges with this project, and I think a big one is around our state management infrastructure. Actually, maybe I'll first talk a little bit about the architecture, the high level. So Plasmic is a React app. It is written in TypeScript. This whole studio is just this React app, and each of these artboards, actually, these things that you're building here, these aren't like WebGL canvases or anything like that. These are real, full-on, DOM web platform things. And so each of these artboards is in fact an iframe recursively housing a React app itself, also a React TypeScript app. So there's a total of 4 React TypeScript applications on screen right now, the studio and each of these artboards. And so there's a lot of state that's going on throughout this app, a lot of very deep state, this whole model, data model, and a lot of properties on each thing. And to keep things performant, by which I mean snappy and like low latency. Like for instance, if I am editing this thing here and I'm dragging this box around, I want that to be, smooth, these drag operations. And what that means is, if you're shooting for 60 FPS, then it's like you have a frame budget of 16 milliseconds. And in order to make sure you're not constantly busting that budget, you just need to make sure you're doing the minimum amount of work that you can get away with in response to any state updates. This is the whole thing with state management, right? Like React by default makes it really easy for you to re-render a lot more than what you need. And if you want to opt out of that, you can, in a way that actually scales with your code base. That's why there's this proliferation of state management frameworks and things like Redux and MobX, and so that's one part of the equation, is just making sure you're only updating what's necessary. But on top of that, latency in the face of scalability is kind of this the main challenge for us. And what I mean by scalability is, right now it's very simple. I just have these 3 artboards, but if I had 100 of these things on screen at once and I wanted to keep these drag operations smooth, how do I do that? Well, you can break up your work into as many small incremental bite-sized chunks as you can, and kind of more incrementally apply that work in a way where you can control the timing, the scheduling, and the prioritization. So one example of this is, let's say, keep an eye, I guess, on the other artboards as I'm dragging around this circle here. So keep an eye on this guy and this guy. Actually, I don't know how clearly you can see this over the Zoom stream, but as I'm moving this thing around, there is a bit of a lag and delay between when I'm, when this guy updates and when the others update. And the reason for that is because rather than, in response to the state update, synchronously doing the naive thing of synchronously updating all of my components everywhere that are bound to that state, we break up that work so that we lazily update things. So this artboard here is the highest priority one to update, and so we immediately update that. But then these other ones are off to the side, so maybe they're a step down in priority, and maybe things entirely off screen are a step down further still. And so that is kind of the high level description of one way that this scalability concern manifests in the code base. Yeah, hopefully that makes sense. Let's see. Another challenge for us is around this feature that I didn't really get to talk about, which is code components. And the idea here is that if you have your own existing components in your code base, or if you use something like Material UI or Ant or whatever, you want to be able to compose new UIs out of those existing components, right? And so there's all this work that is happening for making that possible in terms of, first of all, the module loading infrastructure. So, you probably have some bundling system, some Webpack module system, and how do we piggyback on that work that your bundler is doing, and kind of as a side artifact, actually generate a bundle that you can just throw at Plasmic, so you're not uploading your raw source code or whatever. You're just you're uploading the productionized minified bundle that you would normally publish on the web, etc. And then from there, you can actually make it possible for Plasmic to consume the actual components and evaluate them, execute them. And in order for us to load that in on the Plasmic side, there's a bunch of work that has to happen around securely isolating that third-party code, so that and this is one of the reasons why iframes are handy, is besides things like isolating styles and whatnot, it also isolates the actual whatever, it's a security boundary, right, for these different origins. So that is the module loading piece. And then so now you have these Material UI buttons or what have you showing up in Plasmic, and you can start manipulating that, manipulating these. But how do you do that? How do you actually work with these and configure them and set their properties and whatnot? In order to understand these components, that's where the code introspection part comes in. So there's this CLI that you can run over a code base, this Plasmic CLI, I should say, that you can run over a code base. And what it does is it crawls that code base and finds all the components in it and surfaces those components along with the proper interfaces that they have. So it reflects this out, whether it's documented using TypeScript or prop types or what have you, and it can get a little nuanced, right? Because there are some, a lot of properties that you kind of expect to be able to set through the right-hand rail, as knobs. But there's a bunch of properties also like children props or, function as child props that are things that you would expect to be able to manipulate directly on the canvas through drag and drop and whatever. And so that is, that's what this code introspection piece is about, is understanding and making sense of those interfaces. There's a bunch of product challenges around, I alluded to this earlier, making layout more intuitive and streamlined, because CSS layout is one of these things that I feel like I've worked on forever, and I spend a lot of time trying to understand, but I still feel like I'm so far away from any sort of enlightenment. If just distilling layout into a small set of intuitive controls is recent example. If you just want two text divs to sit side by side and horizontally stretch to fill the available space given to them, you might try setting something like a flex 1, but you may or may not be surprised at the results of that, right? And there's always sort of this explanation. So for instance, in this case, setting flex row to 1 multiplies the flex basis. And whenever you have things side by side like that in a flex direction row, that basis defaults to the width, which in turn defaults to auto. So in this case, it means, and auto means the maximum content size of that div. So effectively, what you have are these two divs that are growing at different speeds depending on the text that's currently in them at the given moment, which is almost never what I want. And I mean, that's actually a really simple example, but there's much more gnarly examples about just like making sense of when does height percentages work, or when do height percentages work and when they don't. There's this thing like used values and specified values on the parent height, and there's certain things that affect the specified value and certain things that don't. And there's just like a lot of ways to cut yourself with CSS layout, and trying to make a layout system that's for humans and for for mere mortals, where the common cases of I just want something to be a fixed size or wrap its content or stretch. These are I think 99% of UIs can be expressed in this way, and so making those unifying the many ways you can do things in CSS into a small package is important. And when I say many ways, I just mean like, there's usually 10 different ways to do something like that horizontal, those side-by-side text divs that I was talking about earlier. Like, why not slap with 50% on them and call it a day? Like, what are the trade-offs with that? So trying to distill a lot of this into like a sane package is, I think, our work is still not done here in terms of making layout intuitive, but I think we have a good start. The other challenge here is that I want to call out is I was mentioning that at the beginning, you can start actually from existing designs that if you work with a designer, maybe they have already created some mockups in something like Figma. And so this is our Figma plugin where it basically automates a lot of the grungy work of translating Figma's their own document representation into web standards. And because Figma and all these design tools, they come from a graphic design background. What that means is they deal with layers and layer masks and blend modes, and in CSS you have things like inner and outer shadows. In Figma you can have centered borders, things like that. So it's just like a lot of tedious work of translating things and learning even about like what you can do in CSS. And there's actually quite a bit you can do. So yeah, there's just like a lot of kind of like small scale design challenges in mapping these, these different representations to each other. But I think this is the most interesting challenge of this whole project, which is the code integration piece. This is the heart of it, right? Which is, if you think about what's natural for visual direct manipulation and what's natural for expressing in code, we are trying to marry the best of both worlds and just trying to find like the most natural, flexible interface, right, for these two worlds. You want something that's flexible, that gives you freedom as a developer, because both for practical, like necessary reasons, like I just need to reflect my real data here, or I need to wire up my real event handlers to my, to my domain business logic. But also more what I'll call quote unquote aesthetic reasons as well. So these are things like, I just want to own the interface to my component. Like I want to dictate what that looks like, what shape that takes. A random example of this is, back in this example, this task component here, this, it takes a children prop, and it can also take, because, we added that states variant to it, it takes a states prop where I can say, I want this to be marks completed, etc. So this is kind of the default interface that it exports, which is pretty simple. But let's say I didn't want this interface. I want it to take actually something higher level, like, my own task, my own domain logic, or my domain entities, like a task object. And I don't want it to take children or whatever. And it should figure out internally what children and what state and whatnot it should be set in. So that's what I mean by owning the interface to components. And that's really important. So basically we arrived at two very different polar opposite codegen schemes. And the first is this presentational library scheme, which I've already shown actually. So it's just this one here where Plasmic generates for you a set of dumb presentational components, and it's really simple, and you can just do what you want with them. And yeah, you can. They're very flexible. So it's a clear divide in terms of what is managed by Plasmic and what is managed by what is your code. It's just like any other NPM library that you pull in. There's a polar opposite scheme, philosophically speaking, which is called the direct edit scheme. And for this one, the philosophy is to give you transparent access to the underlying JSX tree so that you can directly manipulate it and make changes to it as if it were handwritten code. And so this is actually quite fun to show by demo. So what I'll do is I'm going to open up my Plasmic JSON. So I'm going to switch everything over from that presentational scheme to the direct edit scheme, like so. And now I'm going to force blow away all my existing code here. Great. So now my to-do app looks very different from what it did before, right? Before I had the Plasmic to-do app here. Now this is actually a JSX tree that I can directly make changes to and inspect. So let's say I wanted to, delete all these mock tasks, and I actually want these tasks to be rendered based on some loop, a loop over my actual real data here. Let's say I had some collection of things, and I'm looping over that, like so. And maybe maybe this title, I'm going to add a on-click handler to it. For some reason. And maybe I also, because I'm using MobX, I'm going to wrap it in an observer. And let's see. Maybe I'll just add a div to the bottom here. You can just keep making changes directly to this thing. And what happens is I'm going to run Plasmic watch again. I'm going to have the code actually sitting on the right. And so you can see things streaming into the code base. And I'm going to have my editor on the left. And as I make changes to this thing, let's say, I'm going to change this title to be more enthusiastic. And you can see these changes showing up in the code, and my edits are being preserved, right? So I'm also going to edit. I'm going to add a box here in between the title and the contents. Maybe I'll delete some of these. So you can, I'm not feeling super creative, but you can make changes to design, and these it's basically getting merged with your own code edits. And the way this works, it's actually a simple model. It's just a rebase of your developer changes on top of the latest presentational code. This is similar to a Git sort of line-based rebase, if you're familiar with that. But because we have awareness of JSX syntax and all that, we can do something a lot smarter. So things like inserting props and whatnot are semantically meaningful operations. And because we have the history information of this project, we can do that. So we have the common ancestor, the left and the right, the left being like the code edits, the right being the design edits, and we can do that three-way diff and merge like that. So that's kind of how the algorithm works. Yeah. So that is the direct edit scheme. So I think both of these schemes are equally expressive. Actually, it just comes down to kind of your preference and what style you like. But I think predominantly this presentational scheme is the main one that users are starting with. In terms of the, I think this is the last thing I'll talk about, which is just.
Again, real quick, we have a question
please.
from chat. Tao is asking, how is CSS implemented, and can the CSS be edited in the code?
So by default, what the Plasmic tool does is it gives you this editor to create all the presentational components. So the idea is that you don't have to write CSS by hand and figure that out. If you do want to, you can always do that. So it's actually a really flexible interface. Right? Like I can always just directly attach my own class names on things like I don't know, whatever classes you want, or like if you want to just like embed styles directly, you can always override things that way. So it's flexible in that regard. And the actual CSS that is generated by Plasmic, it's similar to any CSS that you would find in NPM, just like plain CSS, right? NPM libraries are not published with the dist folder being populated by like Sass or whatever. It's just plain CSS always, because that's the common standard format for libraries. Anyway, so yeah, hopefully that answers that question. Cool. So the impact on our own workflow, I think this is the first thing, which is that starting with the design actually is a good forcing function for you to think about what is the end goal that you're driving toward, and what is the product experience that you are building toward. And then this is like a very top-down approach, right? Where all the code and logic that you fill in is in service of that goal. And it's nice for, making sure that you're always thinking about what to build and building the right thing. And bottom-up approaches definitely have their place, especially with projects that have high technical risk. But often for projects, it can also be a more bumbling kind of approach. And so this is a good way to make sure you are having a straight line to the end goal. And that you're considerate, I think more importantly, of that, what it is you're building toward. The second impact on our workflow is, if you do work with a designer or somebody who's maybe a little technical, who is capable of wielding a tool like this, then there's something very magical about, like running Plasmic Sync and a nicer version of your landing page appears in the code base. And, this is just a recent example for me personally, but yeah, I think there's something big here where, we definitely want to explore this more. Because so far we've been focused so much on developers this is, as a developer tool, but I think there's something big here. And I think the last impact on our workflow is we had a lot of visual regression tests and things like just manually queuing to see if the design lines up with the implementation, and having storybook plugins that help with this. these are all like obviated because we are already directly just modeling declaratively what we want the end result to look like in the design tool, and that is what we get in the code. I think this is the most fun part for me, which is, we actually just publicly announced this project for the first time 2 weeks ago, and that was a ton of fun. We have a bunch of users now, and these are actually things that some of the earlier users before we publicly announced were creating, and I think this is probably the most far out there thing. This control panel for LiDAR sensors on autonomous vehicles. It's definitely something we never would have expected. But yeah, just a bunch of web apps and mobile web apps and SaaS apps. These are and now the list is a lot longer since our public announcement. Plasmic itself is also built in Plasmic, so I can show you our kind of Plasmic kit project somewhere here. And Plasmic kit is a subset of the UI that we have, and I'll just quickly give you a tour. There's a bunch of stuff I'll skip over, but like our settings page, this is where you generate access tokens and whatnot. Our many forms of buttons, and buttons are actually usually a great stress test for a concept like variants, just because they come in so many flavors that are dynamically combined. Or text boxes and toggles and other primitives. Our share dialog. So this thing is basically this share dialog here. Our code sandbox dialog, which is this guy here. Our many dropdowns. Our left pane, which is there's a lot of sections in the left sidebar here that just need to be designed, and so that's what all these are. Our many icons. This dashboard, which is that home screen where you kind of see, zoom in here. Yeah, this is just the home screen of, listing all the projects that you own. It's this screen here. So yeah, I mean, there's a bunch more stuff that I can show. Yeah, I think that it's it. This is a new thing, so definitely very excited to hear, if you're interested in playtesting this, to hear your feedback. So if you do sign up, just mention this meetup, because then I'll get you your invites right after this, because there is a wait list right now. And otherwise, yeah, we'll be sharing our progress publicly, so feel free to follow us to learn more. There's a lot more projects that we're cooking up. If you guys have any questions, I'd love to field them. That's always my favorite part of these. It's just, chatting. All right, thank you.
Awesome. Thank you, Yang. Cool. Do you want to share, do you have any slides to share? If not, you could at least post the URLs here onto the onto Slack, maybe general channel.
Yeah, happy to do that. So where did it go? Is it events, I guess?
Yeah, you could use events.
So anyway, I'll do that after this, but yeah. The URL, oh, sorry, I closed the window, but the URL is Plasmic app, and yeah, Plasmic app on Twitter.
All right, anyone else have questions for Yang?
Anything goes, no dumb questions. I know I went through this super fast just to kind of stay on track. So.
All right. Well, thanks again. Thanks everyone for coming. And yeah, that was really awesome.
Awesome. Yeah, thank you so much.
All right. See everyone online.